told, plants that are outside the protected area will more likely be medicinal than plants that are inside, because people have, they do not have full access to the flora inside the park. So we will have less medicinal plants inside the park than outside. So that's what we tested here. And we demonstrated that indeed, if you look at the total plants, which means outside and inside abundance, they predict the medicinal status. And when you look at only the abundance outside, they predict medicinal status. But when you look at the plants that are only inside the plant, they do not predict medicinal status. And which means that the prediction here, the correlation that we show here is actually driven by the plant outside. Plant outside means plants that are easily accessible to people. So easy access contributes to the development of medicinal knowledge. So that's what we tested this study, and we provide evidence for it. Now, we provide support for the hypothesis, but there is now a problem in how we manage the protected area. So which means that these evidence mean that protected area are actually limiting the development of traditional knowledge. In this case, the medicinal knowledge. Because in national parks, access to national park is very, very restricted. So by doing so, we are restricting this freedom or this potential of developing medicinal knowledge by restricting access. Which means the way we manage protected area should be revised to allow this knowledge to be developed, because we don't want traditional knowledge to disappear, to go extinct. Most of the drugs today we are buying today from pharmacy, they are based on this traditional knowledge that our parents have developed for centuries. So one way is to actually go for what we call ex situ conservation. So those plants that are restricted to, within the border of the area, we need to develop a plan to have them outside the protected area, what we call the ex situ conservation approach. That's the solution to allow this traditional knowledge development. And then here you have another hypothesis, the last one, the versatility hypothesis, which actually speaks to alien plants. Imagine that when I was coming from South Africa, I bring with me a plant, a seed of a plant that is not native to Nigeria. So that plant becomes alien in Nigeria. Imagine that I bring that plant here and the plant grows in Nigeria. Now the question is, what is the likelihood, what is the probability of that plant, which do not belong to Nigerian flora, what is the likelihood of that plant becoming medicinal in Nigeria? What is the probability of that plant being integrated in the Nigerian medicinal flora? That is what the versatility hypothesis predicts. It predicts that plants that has several uses will stand a better chance of being eventually integrated in local medicinal flora than plants that have very limited number of uses. So that's what we demonstrated here with South African flora, right? That we provide a very good support for the versatility hypothesis. Next one. So here it's just about alien plants. It is about demonstrating that plants that are used for food, medicine, and food, they tend to be non-invasive in South Africa than not. Next one. And here, this is a new hypothesis that we proposed at the time since introduction theory that we proposed. And we propose here the mechanical test hypothesis. Here we only highlight the value of time in the knowledge development. And that's what. So to finish, so you have here a paper that was published like 2 days ago about the botanical education extension. And here because of time. These are the reasons why the botanical knowledge is decreasing, not just in Nigeria, not just in Africa, it's global. And I don't want to go to it. These are the reasons. And this is the problem. If this knowledge is dying, then there's a problem about next one. And then this is the last slide about Nigeria. This is Nigeria, a work that we are doing.